Hi everyone. I'm just going to show a little demo of our ICML 2026 paper, GOTabPFN, which we have a live space on Hugging Face. So you can just go to Hugging Face and search for GOTabPFN, or you can just go to your browser and type GOTabPFN.space. We have a custom domain for that. You can check out our ICML page, project webpage, or GitHub. So if the Jira CPU version doesn't work, you can just try our CPU version, which we already have the link attached to it. I'll just try some basic one. If I select a dataset, I will select the colon cancer dataset. You upload the dataset, it will specify the target column automatically, and then it will say what is the goal. It's saying it's a binary classification. Why? It shows a preview of the CSV dataset, and then you'll have the option to choose your action. So you can just go with full GOTabPFN prediction and or the dataset diagnostics only, the GoLR ordering only, or just the compression part. So I'll go with full GOTabPFN prediction for this demo for now, and it's a type binary. You can obviously change it to multi-class or regression, whatever you need. For parameter mode, there are three options: default quick parameters, manual parameters, and optional tuning. So there's an option for tuning, but I will not recommend tuning on this space because it's on zero GPU and there is a time constraints to do it tuning for people level depth optional trial search. That will be very difficult to complete on this limited time. So you can just check some quick parameters or maybe manual parameters. So I will check with manual parameters. For this dataset, we have reported our best parameters. For the CV mode, there are three options: threefold, fivefold, and 5.5. So we have used 5.5 in the paper. Let's go with that. If you use Optuna, you can just select some trials. I will not specifically use a high number of trials that will require more time, and that is not actually the case for a demo. For the best params, I will go with the best params we have reported in the paper. So for GoLR settings, so GoLR metric, we have all the metrics. So for this dataset, we had Euclidean as the GoLR metric, and the number of cluster, we had 10 in the paper. GoLR refined passes, we had 3 for it. And then the GoLR direction selection, that was true. So we'll keep the tick mark. GoLR feature subsample, we didn't do that for this dataset, so that will basically be 0. Then we'll move to the NSC parameter part. So we have 4 variants of NSC. In the paper, we use NSC PSP. We explained why we use that. So NSC will run with GoLR. And for the NSC segmentation, for this dataset, we will choose equal mass, and then the NSC M rule will be IDF. Tau value will be 0.99. You can change whatever you need for your dataset. The NSC gamma value, that was 1.76. And then NSC beta value, so NSC beta was 0.22. And NSC M min, we had this reported 64. Sorry, I did it in the wrong place. 0.22. Yeah, I should be good now. Yeah, 1.76 and 0.22. And then NSC M min, that was 64. And NSC M max, that is 384. NSC L min, we had this 16 for this dataset. Assume standardize for NSC, that was false, so I will remove this tick mark. The PFN seed was 42. So if you hit the run button, if the 0 GPU is available, you will see the run is happening. And after a few seconds, you will see the results. So I'll not recommend trying with very high dimensional datasets right now. I mean, yeah, you can try, but for some cases, like for high dimensionality, the page might get stuck. So our run is complete. You can see that it shows that the GOTabPFN completed successfully. It shows all the information of what we did, what parameter we selected, and the metric summary. So the results we reported in the paper. And it also displays the class-wise prediction, what happened. Sorry, not the class-wise, the folder-wise prediction actually. And we will also show the label, what level it was for each cases. If you need, you can download this metrics as CSV file, or you can also download this prediction. So we have mentioned that it is not for a very long run, or not for not intended for very long tuning trials. It is just for quick test, maybe quick check. Yeah, and we all obviously can do some other task with this one also. For example, if you want to check the OR ring as OR ring solver, so I will just select the GOELER OR ring only and hit the run button. So you can see that the OR ring is done, and as the OR ring solver, you can see the Mendeley cost as you reported in the paper and the PSP path cost that comes out the same. And if you want to check just like the dataset diagnostics only, you can also check for each diagnostics. It will define what values we have for each of the datasets. Yeah, here we go. We have everything there. The dataset diagnostics, and if you just need a compressed dataset, you can just select the compression part. So the parameters we are selecting for ordering and for compression, that is the parameter we found after hyperparameter tuning for the paper. But if you want to choose some different parameters, that will work also. So once we hit the run for compression, you will see there will be an output for compressed data. So yeah, NSC underscore compressed. So if you need, you can download this file that should be a compressed dataset with reduced dimensionality. So I have already run some other examples. Okay, it's taking some time. Okay, here it goes. So I tried this before with the colon dataset, so I had the same results back then. Yeah, I had the same results with that, and then I tried with the drift phase with the regression. Yeah, it will automatically select the type of problem. If it selects multi-class, you can just change it to regression if you need. And I used the same parameters reported in the paper for this dataset as a regression problem. I had the results as the same results then. And also tested the multi-class problem. So I tested with the Oreos 10P dataset, which had kind of 10,000 plus or around features. So I used the same base parameters reported in the paper, and we obtained the same results. And I will repeat again that this is not for very large data sets. It's for quick test. The runtime set in the space is 5 minutes. So anything small and quick to do, you can just try the live demo. Or if you actually do the paper level work, you can just go and check our code and maybe do the work locally. But if you need some quick test, you can do that. But yeah, you can do higher dimensional data sets, but sometimes that might slow down your pace. So yeah, that's all. Thank you.